definitely to learn something new, to learn what happens in the real life scenarios outside there. So if you aim to graduate from here as an engineer, then definitely you need to put your hands on practice and practical problems that you can apply these principles you will learn here to the outside real life scenarios. This is one of the things. Plus, the second reason you should be here for is that you've been studying lots of theory in there in the lecture, right? Perhaps you understand it. I can guarantee you don't understand from your lecture perfectly. Perhaps you got like 60% of it. So when you come here, see the practical, apply the theory that you learn in the lecture, apply it to the practicals, perhaps you can understand more and you can visualize more than what you learn, or you learn more than what you learn from your lectures. So your job here today is to make sure you came, you sat down there, you look, observe, and understand. Therefore, make sure you understand. If you don't understand, ask the questions. I don't care how many questions you ask, and I don't care how many times you repeat the same question. But if you come and sit here, I want to make sure you understand. That's my job. Here, understandings. And for you to understand things we are doing in the lab, you must understand also the basics, which you should have learned so far from your lecture. If you don't know them, it's fine. Ask, but don't sit there and don't ask the question, and you sit there and you don't understand, and you're sitting there doing nothing. Do you agree on that, guys? Yes? One final thing. Can you hear me, all of you, loud and clear? Okay, I want to hear all of you loud and clear. Your scientific or technical lab report has got a specific structure. This structure must be included within any lab report that you're going to do. Some of which your model leaders, whether for this lab or other labs, they may decide to cancel some of these sections. It's up to them. But I'm talking about in general, this is how you should present your technical or scientific lab report. So you should start your report with an abstract section, followed by introduction section, background theory section, methodology section, results and discussion, then conclusion. These are the minimum basic requirements or the general sections you should include in every report, even in your dissertations as well. These sections in there are standards, must be included with the work that you present. For this lab, and this lab only, the abstract section is not required from you, but you're welcome to add it or not. That's something back to you guys. I'm coming to you. Yes?
Can you repeat, please?
The sections. Okay, the sections again, guys. Abstract, introduction, background theory, methodology, results and discussion, and conclusion. These are the minimum or the standard section must be included with every technical report that you provide. When your assignment brief there, you can read it carefully, follow all the instructions, and as I say to you, how much that works. One thing in there is very important. In the last paragraph, or the one before the last one, the formatting, you don't include any handwritten information in there. So calculations, equations, methodology, whatever you do, don't do anything with your hands. Everything must be typed. Is that clear to everybody? Don't take screenshots of equations, you have to type it. Don't take screenshots of diagrams, you have to draw it on Microsoft Word, PowerPoint, whatever software you're using. You have to provide your work on a typed version. The only picture, the only image you're allowed to include in your report is an image of this bridge in here in your methodology section. You can take a picture of it and include it in there. When you take a picture of this bridge in here, then you have to label everything in there. If this is a sensor, then you have to label it as a sensor. If this is a joint, for example, then you have to label that. If this is a wheel, then you have to label that wheel, etc. You have to label everything if you decide to take a picture of the bridge in here. However, if you want to make it easy, then you can use the one that is provided to you in your assignment. You can take a screenshot of it. Okay? That's the only screenshot you're allowed to include. Is this clear, guys, or not? Now, your assignment made out of two main questions. Question number 1 is asking you to use the method of joints to solve that question. So that's a theoretical method we have to solve that question with. This is for you to do it at home, guys, not here. Question number 1, you do it home, not in this lab here today. Question number 2, we will do it here today. If the question is asking us to calculate the internal forces or find the reaction forces at a specific point on any shapes, taking this bridge here as an example, then assuming this point here, point E or F in this case, and I would like to calculate the internal forces in there. I cannot just come and calculate it, I have to use the initial, one of those initial sides, either this side or that side, depends on the amount of information being given. So assuming I have enough information to start from this side, I will calculate all the internal forces at this joint, then move either horizontally or vertically until I reach from one joint to the other. I will use the results I get so that I can move from one joint to the other until I reach the point that I want to calculate the forces at. Yes? Is that clear? Understood? This is the method of joints. Now talking about the second method, which is the method of sections. I believe you covered it so far in your lectures. What is the method of sections? Show me how would you solve it. So how would you section the bridge?
What I read is that you draw an imaginary line and look at one half of it as a whole structure. The moment that way it has on this one structure, not ignoring the joints.
Okay. Okay, have a seat. Go on. What's your name? Ethan. Ethan, you're right. So Ethan, what he said, we have to section the bridge at specific points. Sectioning means cutting. So we section the bridge. If we're calculating it at E, and the force is applied at E, then we section immediately after that force. Where the force applied, then we section it immediately after the force. Then we cut it. Then we ignore everything after our sectioning or after our cutting in there. We ignore it and we take into account straight here. We don't move from one joint to the other. We use the equilibrium equations with the force applied in here downwards in this case, and we solve the question using the method of sectioning. Okay, moving on from this point, in your introduction section, you have to introduce both methods. You have to explain what is the method of joints, when do you use the method of joints, how it works, same thing with the method of sections, how, when, where, everything about the method of section. You have to introduce it as well as the method of joints. Moving on to the background theory, all the equations that you use across your report must be included within that section in there. So you have to include equation 1, 2, 3, equilibrium equation, moments equations, whatever you use, you have to put it inside your background theory section. Okay, moving on to the third section, which is the methodology. before you start your third section, solve question number 1. So immediately after your background theory, solve question number 1. Fully. Finish question number 1, then start your methodology section. The methodology section is going to be only for question number 2. So, starting question number 2 with the methodology section. We are going to do 2 experiments today. That means we will get 2 practical results today. And you will solve also the same question, question number 2, theoretically. So you will solve the question number 2 theoretically twice. And you'll get 2 practical results. And you have to compare the theoretical with the practical. So 4 comparisons in there, or 4 different results in there. 2 theory results for question number 2, and 2 practical results which you will get out from here today. And you have to compare all of them together. Yes? Any questions? Once you finish your comparison, this is your result and discussion section. Once you finish that section, comparison, explanation, solving the problem. For question number 2, include your conclusion section then. The conclusion section is going to be about both methods. Conclude about question number 1 and question number 2. Okay, now the setup of your experiment here today, we have this structure bridge in here. You have the structure bridge in here, and we are going to apply some forces on top of this bridge. And these forces is going to create, how many types of forces will be created in there? Types of forces, tension, compression and torsion forces, guys. I said it clear. Tension, compression and torsion forces are created once you apply force to anything in there. Of course, there is one more force in there which is called shear force, and you're not required to do anything about the shear force. So we're going to apply some forces to the bridge, and we are going to get the reaction in there. So if I'm applying some forces in here, so you can see that on the screen, the reaction forces are changing. But how do we get that reaction forces in there? So this is a bridge, plastic materials being made out of. The bridge is fixed from one end and free from the other end. This is how you describe your methodology, how you describe your practical experiment, guys. This is a plastic materials being made out of, and we have 6 different sensors positioned at specific locations. Sensors, they take analog signals to the data acquisition system. This is your data acquisition system, DAQ. This is how it looks like. This data acquisition system, they take the analog signal from the sensor, convert it into digital signals, send it to the computer so that the computer can read it and put it out as you can see it, using a data studio software. Now, as I said, we're going to apply some forces in here. The first force that I'm going to apply, before I apply the force, we agreed that we have some sensors there. Those sensors, they take the readings, the internal forces, and record it to us here. Can you see that? The bridge is free from any force. Free from any force. Why do I get some negative and positive forces in there?
Error on the reading.
Exactly. There are errors on these readings, as what you said as well. So there are some types of errors will occur with everything that you do practically. So anything that we do, we will always have what we call uncertainty. But these errors or uncertainties must remain within what we call margin of errors. So we have 2 different types of errors. Could be human errors. Human errors is the way I walk, I move, I handle the experiment equipment. This could be one type of the errors. So we'll create some slight differences in the readings. And also we have what we call technical errors. Technical errors, as what you said here was right, guys. The sensor accuracy, the accuracy of that sensor may not be as accurate, or the precision, as what it meant to be. Plus, also the weights that we apply in there, that weight may have some uncertainties. It's rated 0.5 kilograms on it, but over time, wear, oxidizations, lots of other things, dirt may occur, so will create some false readings. So these false readings, we will always expect that we have some margin of errors, not too much errors. So when you come to compare your results, the theoretical results with the practical one, they will be pretty much similar, but not the same. They will not be exact. If they're not exact, if they're quite close to each other, you're right. Your theoretical solution is correct. Okay? So don't be put off. The theoretical solution not exactly the same as the practical one. Is that clear? So they must be very close to each other. They might be exactly the same, all good. If there are some slight differences in there, don't be put off by that. So it's okay, still correct. But if you have a massive difference in there in the readings, that means you've done something wrong with your, not the practical, because I'm running it, with your theoretical. Yes?
So when you talk about the uncertainties and methodology.
Yes, you have to. You have to talk and mention all of that in your methodology section. The weight that we're going to apply right now, you can see the hanger, which I'm going to put the weight on top of it. It's weighing 0.44 kilogram. It's in kilograms. Each piece of those weighing 0.5 kilograms. So I'm adding 4 of them to make 2.4 kilograms. And I'm applying it at, is it D or E? Sure. Is it D or E?
E.
E?
Yeah.
The first one is E. Okay, so it's being applied at E. And you can see that the force in there is increasing rapidly. So I applied it at E, and we've got the readings in there. So we applied 2.4 kilograms, and we've got the readings in here. We all agreed that tension forces are positive or negative. Positive or negative. So now I would like you to observe this clearly. Look at the first sensor representing the first member in here. This sensor, of course, they are drawn in your assignment, guys. Look at your assignment. You see the positions of each sensor in there. They are represented in this little green box in there. So sensor 1, 2, 3, 4, and 5. So sensor number 1, which is this one here, representing force number 1 in there, which is positive, and you can see that it's on the first member, which is this member of the bridge. Now, as I said, you solve the question theoretically, then compare it practically with these results. That's your first task to do. Second one, I'm going to run the same experiment again. But this time, I'm going to apply 2 kilograms, one at point or joint D, and the other at F. Take the readings. Yes.
What load do you use?
1 kilogram, and the other one is 1 kilogram. So in total, it's 2 kilograms. Yep. Any question, guys?
The first load.
Yes. 2.4 kilogram. That was the first one. The second one is in total 2 kilograms, about 1 kilogram at F and 1 kilogram at D.
And what's the point of load?
The point of load. This is F and that's D. If you take it A, B, C, D, E, F, G, H, and I. Exactly same marking on your assignment. Okay, if you look at the assignment, you will see that being marked in there. Okay, guys? Again, now you're going to calculate or solve the question for the second time. Guys, you will have to solve the question again for the second time theoretically, then compare the results with the practical one. So you will do it twice. For the first experiment, theoretical and practical, then you will repeat the theoretical again, but with these types of forces, and compare them again with the practical one. So you will solve the same question twice, theoretically, and compare them with the double results practically in there. Do you have any question regarding that?